Hello, welcome you all for non-traditional machining NTM. Subject code is 18ME641. Module 5, Introduction to Laser Beam Machining. This is a lecture series 2 and myself Prashantha M V, working as assistant professor in Department of Mechanical Engineering, Canara Engineering College, Mangalore. And if you have any doubts regarding this lecture series, you can ask any questions regarding this through my email ID, that is mvprashantha1985@canaraengineering.in. Welcome you all. Disclaimer: this PPT has been prepared by referring many sources, which includes figures, diagrams from internet as well as from prescribed text and reference books. I do not claim any originality in preparing this PPT or video. This PPT or video is exclusively for the purpose of education and not for any financial gains. I wholeheartedly thank all those who have directly or indirectly contributed to do this PPT or video. Once again, I will thank them all. Next, we will move on to mechanism of metal removal. As you know already, in laser beam machining, the metal removal by laser beam, which is achieved through a combination of melting and evaporation process. Okay. Material removal involves a combination of melting and evaporation processes, and the radiant energy delivered to a surface means work surface, by a focused laser beam. The laser beam is focused through a focused lens, that is a simple lens, and focused on the work surface for a small diameter, means there is a one particular spot. On that spot the laser beam is focused, and focused laser beam is consumed in the following ways. First thing is, a part is reflected and lost. Energy which is not reflected is used for melting. Relatively, a small part is used for evaporating the liquid metal. A very small part is conducted into the base metal, and it is seen that all energy, that is 10 kilowatt per centimeter square. Okay, it's seen that all energy does not reach the metal, as some energy is lost as spatters while traveling. So the energy of laser beam is around 10 kilowatt per centimeter square. So out of which some amount of energy is lost due to various reasons. Okay. Although with some carbon based materials and certain ceramics, the mechanism is purely one of the evaporation process, and when a high energy density laser beam is focused on a small work surface, the thermal energy is absorbed, and which heats and transforms the work volume into a molten state, vaporized state that can easily be removed by the flow of high pressure assisted gas jet, and which accelerates the transformed material and ejects it from the machining zone. By this way, the material removal process takes place in laser beam machining process. Next, we will move on to features or characters of a laser beam. Okay, see, as I told in the previous video, the laser beam has some unique characteristics or property. Okay, here a few of the unique properties I have mentioned. Laser beam, it is a light source having unique properties like monochromatic, coherent, unidirectional or collimated and bright. Okay, see, laser light is monochromatic in nature, that is, its wavelength occupies a very narrow portion of the spectrum. Hence, a simple lens is able to focus and concentrate laser light to a spot of much a smaller diameter and much higher intensity than that obtained by other types of light. Laser light is coherent in nature, means it travels in a phase. Hence, it gives higher focused intensities than a normal light, which is incoherent in nature. Normal light is incoherent in nature and laser beam is coherent in nature. Keep on remembering. And the low divergence rate of lasers is also responsible for high intensity of light. Unique properties like monochromatic or monochromaticity, coherent, high degree of coherence, brightness, high peak power, high energy per pulse and very small size of the focused spot, and wavelength of the commonly used lasers lies between for ruby crystal 0.7 micrometer, NdYAG, neodymium yttrium aluminum garnet, that is 1 micrometer, carbon monoxide 2.7 micrometer and CO2 10.6 micrometers. These are the few of the wavelength means approximate wavelengths for different laser producing elements: ruby, NdYAG, carbon monoxide and carbon dioxide. Okay, see here we have talking about ruby, NdYAG, CO and CO2. So here some different types of lasers are there. So we will study or we will understand the types of lasers used in laser beam machining in coming slides. Types of lasers. Okay, see, there are many types of lasers available for research, medical, industrial and commercial uses. Since the first demonstration of the laser is a ruby laser, it is a variety of other materials have been found after the ruby to operate as a lasers. Okay, as you already known about ruby lasers are still used for a few applications, and but they are not common because of their low power efficiencies. So ruby crystal becomes less efficient at high temperatures, already you known in the equipment and operation. Okay, so basically lasers are two types, that is solid state laser and gas laser. First we will move on to what is a solid state laser. Okay, see here solid state laser, because of poor thermal properties of solid state lasers like ruby and ND glass, neodymium glass, so they can't be used for heavy duty work. Such lasers do not operate faster than 1 or 2 Hertz. Okay, and they are used only for low pulse applications like spot welding, drilling, like operations, etc. However, NdYAG means neodymium yttrium aluminum garnet. NdYAG, neodymium yttrium aluminum garnet. It is also one of the one of the laser producing element, and this laser are most powerful in solid state lasers. See, in solid state lasers mainly two laser producing elements will come. One is ruby crystal and NdYAG laser. These two are solid state lasers, and NdYAG laser is also used for operations like cutting. Its mean power is like less than 1000 watt. It is much lower than CO2 laser. CO2 laser will come in the gas laser. Will understand and study in the coming class or coming slides, and hence it is usually employed for light works. NdYAG laser, it is used for light works. Now we'll move on to gas lasers. See, in gas lasers, CO2, He, CO2 means carbon dioxide, He helium, or N2 nitrogen act as a lasing medium, and these gases are recirculated and replenished to reduce the operating cost. Direct electrical energy is used to provide energy for stimulating a lasing medium. Okay. See, this is the small or brief introduction about gas laser. Here, CO2 laser is a most commonly used laser type, gas type laser. Now we'll move on to CO2 laser. CO2 laser. Look at the diagram. See here, there is a diagram like in the, I will go for part of the lasers. See here, gold coated mirror, this one gold coated mirror, and here stainless steel hollow electrode. This one is stainless steel hollow electrode. See, there is a outer one box like structure, it is covered, so supplying the water inlet and water outlet. And here there is a stainless steel hollow electrode in which, see, the inert gases like CO2, N2, helium gases will move inside, and gas outlet port like this. So see here, there is a coated mirror, and the light will move out like this with a wavelength of 10.6 micrometer. Wavelength of 10.6 micrometer. See, as in the case of ruby crystal, there is a gold coated mirror. It is fully reflective, and there is a partially transmitting mirror. See, this mirror is completely transmitted towards rightward, and here partially transmitting mirror through which the laser will emerges or will move out. And one more, inside there is a tube. That tube is called Pyrex tube. Okay, this is the diagram of CO2 laser. Axial flow CO2 laser is shown in the figure. CO2 laser is the earliest type of gas laser, and it is still one of the most powerful types of laser used in laser beam machining. CO2 lasers are commonly pumped by passing a current through a gas mixture or using a radio frequency energy. You can see to it in the diagram. Okay, and here at the left end of the laser, there is a 100% reflector. I will show you. See at left hand, see this one. Okay, see there is a 100% reflector, and on the right end, there is a partial reflector. And the 100% reflector redirects the photons inside the gas tube, while the partial reflector allows a part of the laser beam that can be used for material processing. And typically the laser tube is cooled externally as well. See, look at here, there is a tube, this is the tube, and because of some actions, the temperature is raised in the inside the tube. So to cool down this tube, there is a one layer is covered to the this Pyrex tube for cooling purpose. Okay, so that is a coolant or cooling system. This cooling system helpful for cool down the temperature of the tube. Okay, here typically the laser tube is cooled externally as well. Due to its high power efficiency, CO2 laser is used for cutting thick metals and also in a welding process. In a CO2 laser, a mixture of CO2, N2 and helium, CO2 carbon dioxide, N2 nitrogen and He helium, these are the mixtures are continuously circulated through a gas tube so as to minimize consumption of gases. Here CO2 carbon dioxide acts as a main lasing medium, whereas N2 nitrogen helps in sustaining the gas plasma, and He helium helps in cooling the high temperature gases. Okay, kindly note down, the CO2 laser produces a beam of infrared light with the principal wavelength bands centering around 9.5 micrometers and 10.6 micrometers. Since CO2 lasers operate in the infrared mode, special materials are necessary for their construction, and typically the mirrors are silvered, while windows and lenses are made of either germanium or zinc selenide. For high power applications, gold mirrors and zinc selenide windows and lenses are preferred. Okay, this is the brief information about CO2 laser. Next we will move on to process parameters. Here power density and laser beam, and between laser beam and workpiece interaction time. Okay, here power density and laser beam workpiece interaction time are the most important variables determining whether the beam will weld, cut, mark or heat treat. Okay, the laser beam having an output energy of 20 joules with a pulse duration of 3 to 10 seconds can produce a peak power of 20 kilowatt. With a beam divergence of 0.002 radians and a spot diameter of 0.05 millimeter can result in a power density of 1.2 watt per centimeter square. See, as I told in the first point, these are the important variables like power density and laser beam workpiece interaction time. These variables are important determining whether the beam will weld, cut, mark or heat treat. Okay, for a rapid heating of a surface without melting, a highly focused beam producing power densities of only 1.5 into 10 to the power of 2 to 1.5 into 10 to the power of 4 watt per centimeter square is used. If melting is desired, as in the case of welding or cladding applications, power densities ranging from 1.5 into 10 to the power of 4 to 1.5 into 10 to the power of 5 watt per centimeter square is used. Cutting and drilling action will occur for power densities ranging from 1.5 into 10 to the power of 6 to 1.5 into 10 to the power of 8 watt per centimeter square. These are the very important process parameters or process variables. Thank you.